My name is Devet. You say it like where you would take your dog. If your dog got sick, you take it to Devet. I work for Sales Loft with Reed here and with Barrett speaking in the next room about machine learning. We build productivity software for salespeople. And don't let the marketing department find out that's how I give the pitch. There's a much better pitch to give. And if you build a SaaS product and you've got salespeople trying to sell it, you should look at Sales Loft. So why did we need, and why might you need, to build a router? So I was wanting to have a picture to kind of show you a little bit of the architecture that necessitated us needing a router. And I figured, well, I don't like drawing pictures. It's not really something I enjoy. But it's 2023. I can just give some text to DALL-E, and DALL-E can generate an image for you to convey what I want to communicate. So for only 10 words in, I'm going to get a picture out, which is supposed to be worth 1,000 words. That's a 100x return on investment. So I said, yeah, here's what I gave it. One server in Europe and one server in the USA. And it gave me this picture, which is wrong only because Europe is in the server instead of the other way around. And so I figured, actually, no, I've got just the right prompt engineer. I'll tell it that I want 2 servers in the US and 1 in Europe, because that's actually more accurately what I want. Let me just get my timer going here. And when I gave it that prompt, it gave me this image. And this image gave me a lot of clarity. That this image really communicates a lot very clearly. Sorry, it's useless to you. You can keep looking at it. You can stop looking at it. It's useful to me. It communicated to me that if I want to convey anything with an image, I need to draw it myself, whether I like to or not. So we have a couple of regions with applications in it. So we have 4 regions in the US and 1 region in the EU when this project started. And when the project started, we had only 1 authentication service running in 1 region only. So this would be bad for users in the EU for 2 reasons. Number 1 is latency. They had all of their data and all of their customers' data that they entered into our system located in the EU, and everything could be accessed low latency. But their authentication experience, logging into the application, OAuth, single sign-on, generating their API keys, all the things that this 7-year-old authentication service did, they need to have a low latency experience for. And so we wanted to take that thing and move it close to them. So latency was the one reason. The other need was GDPR. The authentication service would have their first and last name, their email, their last login attempt would have their user agent and IP address. And so with legal stuff, when you're bumping up against, this needs to be done legally, you want to do it in whatever way you feel comfortable explaining to a judge. In whichever way you feel comfortable explaining it when a lawyer is trying to prove that you did something wrong. And for me to try and explain that having their first and last name and their email and their IP address and their user agent in the US, I cannot try and make the case that that is necessary to provide the service that the user is trying to get from us. So where we wanted to get to is this. We wanted a router in the EU and a router in the US. And there would only be 1 router in the US, even though there are technically 4 regions in the US. But, simplified the picture. And so that a European user would be in Europe, and their request would go to the router in Europe. And that router can decide, OK, if their data resides in the EU, everything's local. If their data resides in the US, we need to route them under the Atlantic Ocean to. And conversely, if a US or EU user is traveling to the other one for business, whatever, the router needs to make the right decision. Solving the 2 main problems of latency and GDPR. Also, and salespeople can say this today, and they love saying it, we meet and exceed GDPR. Because what we ended up with is that the only data for a European user that ends up in the US is their email address and the ID of the team that they belong to. And so that I am okay explaining to a judge. But yes, that was necessary. If that European user comes here on a business trip, we necessarily do need to know that their email address goes with a team that's over there. This thing is bumping against my face. But let me know. OK, cool. Perfect. Requirements, can route a request to the correct region. Cool. It needed to be the source of truth for unique email and to which team that email belongs. So if we're going to take this login service that used to be the source of truth for unique emails, and we're going to replicate it and make it a local, regional thing, then it can no longer be in charge of is an email unique or not. So now the router needs to become the source of truth for is this a unique email and to which team it belongs. We wanted fast lookups for routing. I just want to restate this because we didn't just try and solve GDPR. It was also for latency. Changing your email address or creating a new user where you need to now register a unique email address, that would still be slow. If you're in EU or Australia or anywhere other than the US, you'd still experience some latency. But the lookups of making a request to the system and deciding where do I need to route this request, that needs to be fast and local. OK, so the approach we took was that this router would be a reverse proxy. And I didn't have to draw this picture. Here's how a reverse proxy works. So clients will make a request from across the internet. It will come, and instead of hitting your application servers, it will get to a reverse proxy. In many people's cases, that might be Nginx. And the reverse proxy will then forward the request to the application server, and it will get a response from the application server and forward that back to the client that requested it. So we decided that would be the thing we make that could then decide and be a router and decide, OK, this request goes here, this request goes here. We decided to have a single Postgres database in only one region. So just keeping things simple, Postgres database is what we used before. It is just exactly solves the problem of making sure that every email that gets created is unique, and there's only one of that email that was given out to only one person. And if someone changes their email address, this thing is the source of truth. This is now your email. The other systems need to, treat this as the source of truth for what your email is. We decided to use an ETS cache in all regions for routing data. And how many people in here use Kafka? OK, a few. Good. Kafka is a pain in the butt to set up. It is a pain in the butt to administer. It is phenomenally good at the few things that it's phenomenally good at. But I'm not suggesting everybody else should use Kafka because we use Kafka. Kafka, in our case, was already there. It was already a thing that existed within Salesloft's architecture. There was already a global thing that could be reached from GCP data centers and from AWS data centers. That it was already a transport layer that we could send this data to the other side of the world with. If you are doing all Elixir where you work and you're also using Postgres, something I would suggest looking at for this idea of having a source of truth in one place that you need transported across the world is the Ecto library or plugin that Fly.io creates. It's very clever. Let's imagine your Postgres leader was in the United States, and you are a client in Australia. There might be a Postgres follower in Australia, so any reads you make are local to you and fast. But if you make a write, it is going to send your request all the way across the ocean. And here's the key, here's the clever part. It'll block you as the writer. So you, the writer process, will try to write, and you will be blocked until the bit of data that you wrote gets replicated to the Postgres in Australia with you and is available. Only then are you unblocked. So if you write something and immediately try to read it, you experience the system as if it has strong consistency with the latency that would be necessary for that. However, it is an eventually consistent system with all the benefits of that. So very cool. Of course, you could make a request in a separate process right after you write, and you'll see the, it will not be as consistent as a strongly consistent system. Still, very cool. SalesLoft's library for interacting with Kafka actually does the same thing. That when the writer process gets blocked, until the bit that they wrote, the data they wrote, is back in ETS locally. So as soon as they try and read, they get the correct data. All right, let's talk about Elixir's strengths in that fell out of this process, that was really highlighted here. One was holding on to connections. So as a request comes in to the router receives the request and then needs to hold on to it until it can make an upstream request to the legacy Rails server that can take as much time as it wants to respond. And the Elixir server can only let go of that request after it got that back and can respond to it. So at our scale, globally it's getting about 200 requests per second in that ballpark. And so that can pile up. And, we mainly have multiple nodes for redundancy. I think we've got 5 nodes in the US or 5 nodes in the EU, something like that. But Elixir is uniquely good at doing this, holding on to many connections at the same time. And then Plug places the pit of success right in front of you. And let's look at, I've got one code slide. Let's look at that to see what I describe here. So when a request comes into Phoenix, Phoenix creates a Plug.Conn. And that Plug.Conn is a struct, and it's going to get passed through the entire request response lifecycle all the way to the end. Even your controller is a plug. And when I say a plug, it's a basic module that implements a function that's going to take in a conn, and it will return a conn. Nothing fancy. But let's talk about what that does here, and then I'll step back and talk about the benefits we got from it. So we're looking at 8 lines of code, the most important 8 lines of code in the project. I didn't write them, but turned out to be excellent. Somebody else wrote this. They get the credit. You're looking at the router of the router. And so, OK, Gandalf proxy. OK, this is kind of clever. The auth service is internally called Gandalf because it authenticates you and thou shalt not pass, which I didn't come up with that name, but I dig it. So the first plug we pass that conn into is the region data adder. It will look at the conn and say, OK, can I find region data here? Can I find either a team ID in a path param or in a query param? Can I find a team ID as a prefix to a bearer token? Or can I find an email in an HTML form that's being submitted? So can I find region data? Or is it unknown? Or do I know for sure, based on the path, that this should just go to the closest region? If you're just trying to load accounts.salesloft.com to just put in a username and password, you just get sent to the closest region. OK, so this conn struct that gets passed through all of Phoenix, usually through normal data development, you'll never really do much with it, but you can. Some of the keys there are meant for Phoenix to do its things, but there are some keys there where you can place your own stuff in it. So the region data adder will put region data into the conn, and then the next plug will get it. The region adder will get the region data that was placed in the conn and look up the region. It'll say, OK, I either have an email here or I have a team ID. Let me look up the region. And it will put that in the conn that says region US3 or region EU1. And that goes in the conn. Next, it goes to the parser. The parser will take the request from the client and parse out, okay, which piece of this am I going to form as a request to the server? Next is the proxy, which is going to make a request to the upstream service and get a response. Next is the SAML ID name comparer. And this is a piece of debugging code that was put in later because SAML can be a pain in the butt to debug. And maybe I'll pause here. I'll step back at the end and talk about benefits we got. But here is a benefit of this programming pattern in Elixir that was then used in Phoenix, is that if you've got a pipeline of functions and they all take in the same type of thing and respond with the same type of thing, you can very easily put things in the middle of the pipeline at any point, as long as they adhere to the contract. And very lastly, we respond to the client. So the main benefit we got from this is during the course of the project took a bit long, and I'll get to that later. During the course of the project, we had 2 different junior engineers join the team, and at 2 different times. One of them joined the team, got promoted to mid-level and moved to a different team. The other one joined the team, got promoted to mid-level, and is still with us. She's an excellent engineer. But both of them, this was their first job delivering software. And for both of them, they'd never written Elixir code until they showed up here. And I apologize, day one, to each of them. I am sorry that this is your introduction into delivering software. That this is not building a custom reverse proxy router is not a gentle introduction to building software. And to be fair, we explained the whole thing, but we didn't try to get them to understand an overview of how the whole thing works and expect them to be able to work on all parts of it. But because of how this was set up, most features that needed to be added was in the region data adder. It needed to receive a new type of, we'd figure out from Datadog metrics that, okay, here are all the requests that we are seeing. We don't know how to route these. So they'd need to go figure one of those, okay, it's coming in with routing data. We could write in the Jira card, here's the routing data. It's in the query params. Go write the code to take that routing data and put it in the con. And after a couple weeks of pair programming, a junior engineer would independently start delivering value on this thing, which I think was a huge success. And also, every time we had to add a feature or fix a bug, it was either in one of these modules that we needed to add something or fix something, or in 2 of them, where one module needs to add one more thing to the con, and a later module needs to read something out and do something with it. And I wanted to, okay, the point I was trying to make with all that, the slide I spent the most time on, is that you could make the argument that, well, it could be done that way in any language. Right? The programming language doesn't matter. And usually, if I talk about the benefits of Elixir, I would talk about the runtime. If we look at my last slide, it was talking about being able to hold on to connections for a long time. That's about the runtime. It's got nothing to do with the syntax. And my next slide is also about the runtime. But this one is actually about the syntax. And generally, the syntax doesn't matter that much. But in this case, I believe that the pattern that Elixir encourages of having a pipeline of functions that passes data through them, and then the plug architecture that Phoenix is built with, encourages you to think about your problems in this way. And it encouraged us to break down a very complex problem into simple steps that, if you try to go work on any one of them, is actually really manageable. So yeah, and if you're not familiar with the term pit of success, it's when the thing right in front of you that you might just stumble into is the success path. That you just kind of do the obvious thing and it ends up being very successful. And it adds minimal latency. And here's one that I want you to be careful if you work with people who are not Elixir enthusiasts, or you're trying to convince an employer or a client to build something in Elixir and they might be skeptical. Be careful to try and sell them on latency or concurrency or stuff. Usually the nerds care about that, but if it's not solving a real business problem, it doesn't matter. And most of the time it doesn't, because the users can't tell a difference if they're going to load a page Whether the server took 1 millisecond or 180 milliseconds to render that page, or to come up with that response, the users usually won't tell the difference. However, if your system has multiple services that need to take this request, if you already have a legacy thing running that already might take 180 milliseconds to respond, then if you put a thing in front of it that adds 100 milliseconds, now you're in territory where the users would feel that it's slow. So Elixir being low latency sometimes is important to the business, and in this case it was. It didn't have to be that fast, but it's fast. So that line in the middle there is 1 millisecond. And this is this week, let's see. Yeah, it's Tuesday and Wednesday. So it is just incredibly stable around 1 millisecond. And the 1 millisecond, here's how it's counted up, is the time spent in this router that's not spent proxying. So not the time that we were waiting for the Rails server to send its response, but the time that we actually spend getting a small request in, making a few transformations to it, looking up routing data in ETS, and then later formulating a response. It is you can see a slight increase in response time during the middle of the day around 12. I guess that first 12 must be Monday, because there's not much of an increase. It was Labor Day. But the other two have a tiny bump. But yeah, it's ridiculously fast. It did not need to be 1 millisecond fast, but latency was important. OK. Oh, and by the way, we didn't spend any time trying to make it fast. We didn't spend any time optimizing or, we just try to write the code so that it's easy for people to read. And surely, sometimes you need to, go massage it to make it faster, but Elixir was just fast. Some pitfalls. So some things that did not go as smoothly. Hop-by-hop headers. So you can Google these. It is when there's a client and some kind of a thing in the middle, and then the final thing they're going to. There might be an agreement between them on which transfer protocol they're going to use. And so the server might be sending a response back with a header that says, OK, here's your response. Here's the transfer protocol. I'm sending it to you all at once. Or I'm sending it in chunks. This is not yet all of it. I'm going to send more stuff. And it just if you forward these along, because naively we would just take the request from the client and forward the whole thing up, and take the response from the server and forward the whole thing down. And we ended up forwarding hop-by-hop headers, which was only meant for us. As soon as it's literally just making a list of headers you want to drop and deleting those from a list, then it worked. It was just a bit, the error messages were not clear. That was the only low-level thing we had to learn. For a team of people that are not network engineers or network programmers, this was the only thing that we're like, oh, this is lower level than what we normally deal with in our day-to-day job, is dropping some headers. Another pitfall was flexing how much we can do with very little resources. So this thing would run in production using less than 500 megabytes of memory. And if you remember, I said there was one router for all of the US. And so that is a single point of failure. And what happened was, we said, well, if we always use less than 500, let's say that we limit to 600 megabytes. It's never gotten anywhere close to it. And so now we get to show, hey, look at us. We built it in Elixir, and we can handle so many requests with so little resources. Well, guess what? Nobody cares when it goes down, because one of the regions had a database outage and started request queuing. And so 200 requests per second coming in, a subset of them are just queuing and piling up, so the router ran out of memory. And a database outage in one region resulted in an outage for all regions. So yeah, we could have spent a bunch of time finding very clever ways to resolve that, but in the end, just giving it 2 gigs of RAM means we'll never run into it again. So that was a pitfall. And here's probably the main pitfall, probably the main thing about the whole project that didn't go very well, is that we couldn't cut any scope. This legacy authentication service does a whole bunch of things. You could log in with username and password. You could log into it with different single sign-on providers. You could make your API keys with it. It's a OAuth client at times. It's an OAuth, you know, all kinds of things it does. OpenID Connect was involved. So we needed to make sure, if we're going to take that thing and say that, OK, your data is no longer here globally, we can no longer just send you to a default region, and you'll be able to sign in there, find your data there. We're going to move European users' data to Europe. The moment we did that, it either had to all of it work, or some of it's not going to work. And you can't cut scope and say, well, you know, we've got 7 years of history of different features we've built. We'll just let a subset of it work for now, and you know, some of it'll just be broken, and we'll get user feedback on which they want unbroken faster. No, it all had to work on day one, which meant that when we discovered complexity along the way, it would just push back the delivery date, which was, yeah, very uncomfortable. So, build a proxy, it'll be easy. This is what I'm leaving you with. Sequin guys, this does not apply to you. They're building a Postgres proxy. This is different. I'm talking about an HTTP proxy. HTTP proxy will be easy. Postgres proxy sounds hard. So if you need a proxy for any reason, I've got regions on the brain. If you need a proxy for any reason, there's a book, Adopting Elixir, that Jose Valim co-authored. And one of the patterns in there is the strangler pattern. That if you've got some legacy Java or C# or Ruby or Python or Node, I just want to equally offend everybody. You got some legacy application, you could put a proxy in front of it, an Elixir proxy, that all of the request comes through Elixir to the legacy service, and then you can one by one decide when you want to start handling that request in Elixir and not send it to the upstream thing. What I'm here to tell you, and what you can be angry at me at if it doesn't work out that way, is that just setting up the proxy part will be easy. It's how many features you then need to replace, and how are you going to reach back to the legacy database and all that stuff. That stuff's going to be hard. But the proxy part, yeah, I don't think it's hard. And if you need to build a router, consider how many different types of requests you need to route. If you've got 500 endpoints for some service and you're routing all of them, but each and every one of them have a bearer token, and you can prefix that bearer token with some ID, and you can route on that ID, building a router will actually be easy. The whole thing will be easy. The difficulty for us came in that we've got many different services calling this authentication service, and not all of them are including routing data. Or the routing data could be in different places. It could be in a path param, or a query param, or a bearer token, or in a cookie. So if you need to look at maybe, oh, well, we also want to get this GDPR benefit, we might need a router at work, I want you to think carefully about how many different types of requests you need to, how many routing strategies will you need to have, how much different code is going to have to parse, how many different types of requests coming in that could be routed in different ways. All right, so with that, we're done. Any questions? Thanks.